So here we are drawing Born Haber cycle of sodium chloride, starting from sodium in its natural state plus chlorine in its gaseous state. Okay. So these elements, they can form directly ionic lattice of sodium chloride. Ionic lattice of sodium chloride. So balancing the equation, we can write half moles of chlorine gas. So obviously, the enthalpy change taking place for the direct formation of ionic lattice from its elements in its natural state, it will be standard enthalpy change of formation of sodium chloride. Right? So now in the first step, we are changing sodium from its natural state to gaseous state. Right? Sodium atom in its gaseous state, keeping chlorine the same. So here, the enthalpy change involved will be standard enthalpy change of atomization for sodium. Right? And the value according to data booklet is plus 107.3 kilojoule per mole. Okay. In the second step, we are going to change chlorine from its gaseous state or diatomic gaseous state to atomic gaseous state, keeping sodium the same. So chlorine in atomic state. So enthalpy change involved will be standard enthalpy change of atomization of chlorine. And the value of standard enthalpy change of atomization of chlorine is plus 121.3 kilojoule per mole. Now you can see that sodium and chlorine, they have become now in gaseous state, atomic gaseous state. So the next is we have to convert sodium gaseous state to sodium ion, and obviously it will be an endothermic process. So on the energy level diagram, it will go up. Energy difference or energy change will go up, and sodium is becoming sodium ion in its gaseous state. And enthalpy change will be, because sodium is losing one electron, 1 mole of sodium each are losing 1 electron. So standard enthalpy change of ionization energy, and that will be ionization energy for sodium. Right, and the value is plus 495.8 kilojoule per mole. So sodium has become sodium ion by losing one electron, and that electron, the lost electron, is gained by chlorine atom in gaseous state. So for this purpose, for gaining one electron by chlorine atom in gaseous state, the enthalpy change will be electron affinity. So electron affinity will be, as it is an exothermic process, so on the energy profile diagram, it will go down, right? So enthalpy change at a standard condition, electron affinity. So chlorine will become chlorides in gaseous state, and sodium has already formed cation in gaseous state. Okay, so now you can see that sodium ion and chloride ion, they both are in gaseous state. So when they combine together, to form ionic lattice, so enthalpy change will be lattice energy. Enthalpy change will be lattice energy, standard and standard enthalpy change of lattice for sodium chloride, right? Or you can simply write as lattice energy LE of sodium chloride. So this is the Born Haber cycle of sodium chloride, as you can see that. So when we will apply Hess's law, so we can calculate energy. So this is the direct step. So direct step will be equal to the sum of all these steps to find out the lattice energy. So this is how we can calculate lattice energy. So first of all, we have to arrange. All right. So so now we are going to calculate lattice energy using Born Haber cycle. You know that Born Haber cycle is based on Hess's law. So according to Hess's law, we can write as sodium sodium ion in gaseous state plus chlorine ion in gaseous state. Okay, they form ionic lattice of sodium chloride, and these, as you know, that these ions are not in natural state. So sodium in a natural state is solid, and chlorine is in natural state in gaseous state, right? So balancing the equation of, so this is the direct step where sodium and chlorine, they combine to form ionic lattice of sodium chloride, and the enthalpy change at the standard condition of formation. This is the direct step, and these elements, sodium and chlorine, they first change into ionic form, ionic states, and this reaction can be denoted by standard enthalpy change of 1. And this is obviously standard enthalpy change of lattice energy, right? So this is the direct step, and first sodium and chlorine, they are changing into sodium and chlorine ions in gaseous state, and then they form sodium chloride, right? So we can use this idea for calculating lattice energy, right? So lattice energy is basically, we can say that the direct step standard enthalpy change of formation is actually standard enthalpy change 1 plus lattice energy. So we can also write as, because we are going to calculate the standard enthalpy change of lattice, so subjecting the standard enthalpy change of lattice is equal to enthalpy change of formation minus enthalpy change 1, right? So now we can, because you know that standard enthalpy change 1, the formation of gaseous ions are multi-step process. So as we have done in Born Haber cycle of sodium chloride. So we can elaborate, or we can extend to calculate a standard enthalpy change as, for example, if you, in one step you are changing sodium into sodium gaseous ion, and in the second step you are changing, and just accumulate or combine both the calculations to get the standard enthalpy change 1, right? So in the first step, you know that sodium solid form using a standard enthalpy change of atomization. You changed first sodium atom in gaseous state, and then you changed in sodium ion in gaseous state before the formation of ionic lattice. So here, the standard enthalpy change of atomization, the enthalpy change was atomization of sodium, and that was plus 107.3 kilojoule per mole. And from sodium gaseous state to sodium, this the standard enthalpy change of ionization or ionization energy, and the value of ionization energy for sodium is plus 495.8 kilojoule per mole, right? So the total energy for sodium, for the total energy change from sodium in its natural state to sodium ion in gaseous state will be plus 107.3 plus 495.8. So it becomes 603.1 kilojoule per mole, right? Now chlorine, from chlorine to chloride, right? From chlorine, in its natural state to chloride in gaseous state. So half moles of chlorine as in gaseous state, you changed first into atomic chlorine in gaseous state, and then atomic chlorine changed into chloride in gaseous state, right? So obviously, in atomic for the formation of atomic chlorine, standard enthalpy change. The enthalpy change involved is standard enthalpy change of atomization of chlorine, and the value of standard enthalpy change of atomization of chlorine is plus 121.3, and standard enthalpy change of electron affinity, or electron, simply saying electron affinity, is minus 348.6 kilojoule per mole. So combining these two values, you will find plus 121.3 plus minus 348.6. So the total value for total enthalpy change for the formation of chloride in gaseous state from its natural states will be minus 227.3, okay, kilojoule per mole. So these two are collectively a standard enthalpy change 1, which we have mentioned over here. So standard enthalpy change 1 is the sum of these two, right? So standard enthalpy change you can write as 603.1 and plus minus, so minus 227.3. So that value will be plus 375.8 kilojoule. So the standard enthalpy change 1 will be equal to plus 375.8. So putting the value of standard enthalpy change 1 and enthalpy change of formation to get lattice energy. Okay, so finally we are going to calculate lattice energy for sodium chloride is equal to standard enthalpy change of formation, which is minus 410.9 kilojoule per mole minus 375 minus plus 375.8. So it becomes minus 785.8 kilojoule per mole. So this is basically the standard enthalpy change of, this is the lattice energy basically for sodium chloride. Okay, thank you very much.